When I was a teenager, Frank Herbert's Dune was one of my favorite novels. For those of you who've never read it, it's a science fiction story that takes place on a hot, dry planet. One of the most intriguing things about this book to me was the way in which the protagonists of the story would don their still suits before they went down into the desert. To me, the most interesting part about the still suit was the way in which it captured the moisture and bodily wastes of its wearer and cleaned the water so that they could drink recycled water from a straw mounted next to their mouth. 25 years after I first encountered Dune, I reread it with my daughter. By this point, I was a professor at UC Berkeley studying droughts in Southern California. Rediscovering this treasure of my youth made me wonder, could we build a still suit for an entire city? When I pondered this question for a while, I realized that in some ways we're already doing it. By passing water through reverse osmosis membranes, adding a small amount of hydrogen peroxide and exposing it to ultraviolet light, engineers in Orange County, California had been turning what used to be considered useless wastewater into drinking water for over 25 years. The difference was that after they passed the water through the advanced treatment process, they injected it into the groundwater aquifer, where it spent 6 months before it was pumped out and returned to the water supply. Over the past 2 decades, this practice, which is called potable water recycling, has gradually spread from Southern California to Arizona, Texas, Georgia, and Virginia. And as the practice has spread, our research team has developed state-of-the-art technologies for measuring chemicals that might sneak through the recycling process. We've also begun to open up entire sections of wastewater effluent receiving rivers to sunlight. The sunlight breaks down chemical contaminants, inactivates waterborne pathogens, and makes it easier for the downstream city to recycle the water. Now, in the early days, the skeptics said that as potable water recycling spread and the public became more aware of the connection between their drinking water supply and the sewer, they would be repulsed. But that hasn't been the case. Researchers at UC Berkeley have shown that as the public becomes aware of the water recycling technology and familiar with the professionals who operate their treatment plants, the initial fears tend to recede. Over the past decade, we've seen increasing interest in potable water recycling as droughts have emptied the reservoirs in California and Texas and Brazil and Australia. In many cases, the interest in recycling disappears as soon as the rains return. But increasingly, we're seeing enlightened public officials who recognize that droughts are just a wake-up call to get us prepared for the hotter and drier conditions that will exist as our climate changes. But there's still a problem. Our still suits leak. Over half the water that we use in our cities doesn't return to our wastewater treatment plants. In a typical American city, about 20% of the water that we put in the pipes never even makes it to our homes. Now, if we were to invest more money in our neglected water infrastructure, we might be able to plug these leaks, but we'd never be able to completely close the urban water cycle. That's because we're always going to need some water to support trees and foliage that shade us from the sun, cool the air, and provide us with recreational opportunities. Now, it might be possible to refill our still suit by capturing the water that falls on our roofs and roadways and lawns and returning it to the drinking water supply. Here at UC Berkeley, we're developing cost-effective ways to purify rainwater and gradually percolate it into the aquifer to make up for the water that's lost through irrigation and leaks. But even if we were able to do this, it wouldn't be enough. There's still another problem: the location of our sewage treatment plants. As you might imagine, when it was time to start building treatment plants, the most logical place to put them was at the end of the sewer pipe. That means that our wastewater infrastructure tends to be located on the waterfront, where the effects of sea level rise and coastal flooding are going to be worse in the future. Here at UC Berkeley, we're developing 2 solutions to this problem. The first one is to use the water that remains after the recycling process to create a series of coastal wetlands that protect our flood control levees from storm surges. The other is to completely abandon our centralized wastewater treatment plants and build distributed recycling plants throughout the city. These miniature treatment plants will be equipped with many of the same technologies that we have in our centralized plants, but instead of having a staff of full-time operators, they'll be run remotely with sensors and actuators. When we come back and think about the still suit in Dune, we realize it wouldn't be a very practical solution for people living in a dry city. But an unobtrusive system of technologies that allows us to safely recycle water is no longer the stuff of science fiction. It's the future that we're building here at UC Berkeley. Thank you.